In this video, we're going to translate sine and cosine curves horizontally. So before we do that, let's just do a quick review of all of the different variables in our functions. So when I look at the a value, the absolute value of a, or the positive a value, is the amplitude. So that is our height of our curve. That is also the vertical stretching or compressing. If we have a negative a value, remember that that means that we have a reflection over the x-axis. So that tells us a vertical flip when we think about our acronym HIVO, vertical outside. So the negative on the outside tells us a reflection over the x-axis. The b value tells us how many cycles, so this is the number of cycles in 2 pi, in 0 to 2 pi. Remember, that is not the same as the period. The period is the length of one cycle. B tells us how many cycles from 0 to 2 pi. And then the h value is the new part today. So the h value is going to be our horizontal movement, because notice that it's in the inside of the function. So horizontally, we do the opposite of what we would think to do. So a horizontal shift, so the right or left movement, is the h value. And when I say we're going to do the opposite of what we would think, if it's a negative h, well, that means we're going to go right h. And if it's a positive h, well, then we're going to go left h units. And then the k value we saw already when we did our midlines. This is our vertical shift. So today is really going to be tying it all together. So taking a graph and now basically having any of these scenarios. So if we look at this first example, we want to graph one complete cycle of this function. So when we kind of dissect this equation, let's look at what each thing means. So I have a 2 in front. So the 2 is going to be my amplitude. And remember, it's always positive. The period is based on whatever the b value is. So the b value here is just equal to 1. We don't see a number there, but it's equal to 1. So that means the period is 2 pi divided by that b value. So 2 pi divided by 1 is 2 pi. In order to figure out our labels, we're always going to divide that by 4 to represent each of the key points on the unit circle. So we have 1/4 of 2 pi, or I could just say 2 pi divided by 4. I'm going to actually write it like that. That's probably easier. So this tells me pi over 2. So that means each label that I care about is going to be an increment of pi over 2, which this is our standard graph that we typically see. But remember, for our labels, so it's 1 times pi over 2 will be our first label, so that's pi over 2. Our second label will be 2 times pi over 2, which is pi. 3 times pi over 2, which is just going to be 3 pi over 2. And then 4 times pi over 2 is just going to be 2 pi. So again, these are just our standard labels because they represent the quadrant angles. I'm just going to switch this to make it look more like a 2 there. So then now when I go to graph this, I really want to consider that horizontal shift in there, because notice that's not one of my key characteristics. I see that the midline, there's nothing added at the end, so I'm going to go ahead and just write this. My midline is just going to be y equals 0, so it's just going to be the x-axis. I don't really need to worry about that too much. The range I'm going to save till after I graph. So then the question becomes, well, how do we take care of the horizontal shifting? So for the horizontal shifting, I would recommend graphing your parent function, or basically the function without the shifting, because I still want to include the amplitude and the b value and all of that. I just don't want to include the horizontal shifting. So we're going to actually do 2 steps for this. So the first thing I'm going to do is I'm going to graph without the shift, without the horizontal shift. So I'm going to graph y equals 2 cosine of x. So I'm going to do this first. So I'm going to go ahead and do this just how we've been doing it. So I have, it looks like if I go up by 2's here, that'll be good for my labels. So pi over 2. Then I have pi. 3 pi over 2, and 2 pi. And something that's important to think about before you actually get too far into the graph is where will this end up? So if you look, I have with this shifting here, this plus pi really tells me that I'm going to be moving my graph left pi units. So I want to make sure that my scale is actually going to allow me to do that. And if I look at my graph, well, I went up by pi over 2, which just basically means I'm going to move 2 of these intervals when I move left pi units. So I'm actually going to include some negative units on the left because I'm going to be shifting my graph left pi. So that's why we're kind of centered here. We have our y-axis in the center. So let me go ahead and write that. I'm just going to write it over here. We're going to go left pi radians. So I'm going to start with, let me go ahead and get some labels on the left-hand side. So this is going to be negative pi over 2. This will be negative pi, negative 3 pi over 2, and negative 2 pi. And I'm going to go ahead and start with my cosine y equals 2 cosine x. So I'm starting at the x-axis. So I'm going to go up, and for this I'm just going to do going up by 1. So I'm going to call this 2 and this negative 2, just for making it easier if they're, with midlines and that kind of thing. So I'm going to start up at 2. I'm going to go down to pi over 2. Then I'm going down to negative 2 at pi, back to 0 at 3 pi over 2, and then back up to 2 pi. And then for this one, I'm going to draw it as a dotted curve because I want it to look different than my final graph. This is kind of like my in-between step. We are going to have 2 graphs on our page, so we want to make sure that we label those. I think color is really helpful here too. So if you have something erasable that's color, I definitely recommend using that. And then now if I go ahead and take this, I'm going to shift it pi radians to the left. So remember what we said, pi radians is actually 2 of these intervals that we blocked off. So each point is really going 2 intervals or 2 sections here to the left. So I'm going to move each point 2 sections. So 1, 2, 2 of my equally spaced sections, 1, 2, and then 1, 2. And that's really going pi radians. So now for this one, I'm going to make it a solid curve because this is actually the answer to the question. The other graph is just my helper graph. So y equals 2 cosine x plus pi. So not a whole lot different as to what you've seen before. It's just adding in an extra step. So let's go ahead and keep trying a couple more. And then really we'll just have you finish up the rest of these. So let's try a couple more together. So the next one, graph 1 complete cycle. So again, one length here or 1 period. So when I look at this, I want to kind of dissect it into what are each of the different categories, but I also want to figure out, well, what is the function or my helper function without the horizontal shift? So basically my horizontal shift is this plus pi over 2. So the helper graph is going to be everything except for that plus pi over 2. And that's what you've graphed before previous to this video. So the first thing we're going to do is we're going to graph y equals negative sine 2x minus 2. So we're going to start with that. And again, when I go to write this information, these 2 graphs, the equations are going to match. I just need to make sure I talk about that pi over 2. So let's go ahead and do that right now. We know that in the end, we're going to have to move left pi over 2 radians. Again, it's left because it's a plus pi over 2. So since we're horizontally, we're doing the opposite of what we would think. So then when I go to write all of this other stuff in there, the amplitude is just going to be the number in front here, which is just going to be 1. But because I have a negative, I'm going to make a note to remind myself I am going to have to reflect over the x-axis. The period is going to be 2 pi divided by the b value. This is our b value right here out in front of the parentheses. So that tells us that there's 2 cycles in 2 pi. So to find the length of 1 cycle, I'm going to do 2 pi divided by 2. So that gives me pi. My labels are going to be that pi divided by 4. So each increment is going to be pi over 4. So again, for the labels, you can list these off to the side if it helps. So I have 1 times pi over 4 is just going to be pi over 4. 2 times pi over 4 is going to be pi over 2. 3 times pi over 4 is 3 pi over 4. And 4 times pi over 4 is going to be pi. And again, I want to make sure that my shift here, the pi over 2, is something that I can do with these labels. So if you look, pi over 2 is actually 2 equal intervals again. So all that means is if I stick with these as my labels, when I do the shifting, I'm going to be moving 2 intervals or 2 sections. Um, so we can go ahead and label. I'm going to just equally space this out by 2 just so I know that it's going to fit. Same as the last problem, I'm going to want to put some values on the left because I know I'm going to be going left pi over 2 radians. So I have pi over 4. I have pi over 2. 3 pi over 4 and pi. And then I'm going to do the left as well. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. My midline for this is going to be the number at the end, so y equals negative 2. So for this one, I'm going to, again, go up by increments of 1. So I'm going to call this 2, and this is going to be my negative 2. So let's go ahead and draw in that midline. I would use another color, highlighter, or something for this midline. So that we know that it stands out as where we want to measure everything from. It's kind of like our new x-axis, but it's not really part of our final answer. So another color is helpful because otherwise if you do everything in pencil, everything is going to look the same. Or you could do it as a dotted line too. That would work. So that means now when I go to do this, I can start my equation. So I'm going to graph that first one in purple. So I'm doing y equals negative 2 or negative sign 2x minus 2. So I'm going to start at my midline. That's how I'm taking care of the ending. Since this is sine, we're going to start at 0. So basically we're starting in place here. And then we're going to go down first instead of up since it's a negative. So it's going to be down 1 unit, then back to 0 or back to my midline, and then we're going to go up. So this one's kind of hard to see. I'm going to make that point extra big just so I remember to include it, and then back to the midline. So when I do this dotted, I'm going to write this equation, y equals negative sine 2x minus 2. And then from here, I am going to shift everything left pi over 2 radians. So that means, again, it's 2 sections on my graph or 2 intervals that represent pi over 2. So each point's going to go left 2 intervals. So that's going to be the first point. 1, 2 is the second point. 1, 2 for the third. This big point here is going to go left 2. And then this point is also going to go left 2. And this one I'm going to go ahead and connect. I'm going to redo that one. I'm going to connect this with a solid curve. Again, do your best to make these look curved. This one's not looking too hot, but that's okay. At least you want it to look curved. You don't want it to look like it's linear for sure, or an absolute value or something like that. So this is going to be the final answer. Y equals negative sine 2 times x plus pi over 2 minus 2. And then the range, I think I forgot the range on the last one, so let's bounce back up and do that in a second. But the range for this one is down at, remember, starting at the origin, we went down to negative 3. So negative 3 and then back up to negative 1. Remember, you're always listing that smallest to biggest, making sure that you use the original y-axis, those labels, not using like your midline. Don't start at your midline for the range. If I bounce back up to the top, I forgot to do the range here, but so if I look at my turquoise graph, negative 2 to 2 is going to be the range on that one. All right, let's go to the next page. I think there's a unique one on the next page. So let's look at that one. And then maybe we'll look at two more together, I'm thinking, and then you guys can finish up the other ones on your own. So if we look at the next page, we have for number 3, we have to graph one complete cycle. So again, starting it off the exact same way. My helper is going to be without the minus pi over 4 because that's going to indicate that I'm actually going right pi over 4. So I can write that down here just as a reminder that that's my horizontal movement this time is going to be right pi over 4 radians. And then my helper graph is going to be, so we're going to graph y equals 2 cosine 2/3 x first. So the amplitude of this is going to be 2. The period is 2 pi divided by the b value. So our b value is 2/3. So we're at 2 pi times 3 over 2. So this is just going to end up giving us 3 pi. And then the labels here are going to be 3 pi divided by 4. No vertical shift, so the midline is just equal to 0. And the range will save for the end. So when I go to look at this, we have to think about our labels and we have to think about this pi over 4. So this one's interesting because if we go to do our labels off to the side here, we have 1 times 3 pi over 4, which is just 3 pi over 4. 2 times 3 pi over 4, which is going to be, so that's going to end up being 3 pi over 2. And then 3 times 3 pi over 4. So this is going to be 9 pi over 4. And 4 times 3 pi over 4 is just going to be 3 pi. So for this one, what's interesting is our pi over 4 doesn't fall in this interval. But if you notice the period, or notice the first label is 3 pi over 4. That means you have 3 pi's over 4. Or you have 3 of the pi over 4. So what we should do for this is if we label every 3 boxes as 3 pi over 4, that would make each box pi over 4. So I'm going to write label every 3 boxes. That's going to allow us to do our shift. So if I label every 3 boxes here, and this first interval is 3 pi over 4, that means each of these individual boxes is actually pi over 4. So that's how we want to handle this so that we can actually do the shift. So then the next one here is going to be 3 pi over 2. This one's going to be 9 pi over 4 and 3 pi. Now for this one, I don't need to go on the left because I'm going to be shifting to the right pi over 4. I'm only going to be shifting right 1 box is really what's going to happen here. So now when I go to do my first graph, my parent function or my helper function, I'm going to, again, let me label these two. So my y-axis, I'm just going to go up by 1. So this will be -2 and then 2 up top. So when I go to do cosine, I'm going to start up at 2. And then I'm going to go down to -2, back to 0, up to 2. This is my helper, so I'm going to make it dotted. We'll label this as the helper. And now I can do my shift. So for the shifting, I'm going to take each of these points and only go 1 box because 1 box is equal to pi over 4 radians. So 1 box to the right, 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 and 1 box to the right. And now I can go ahead and connect. And this is going to be my final curve. Y equals 2 cosine 2/3 x minus pi over 4. And if we needed to label this last box here, this is going to be, remember this is going up by pi over 4. So let's just count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this last box here is actually 13 pi over 4. Right? There's 13 of them because each section here. So if you needed to write the domain, this is going to go from pi over 4 to 13 pi over 4 is the domain of our shifted function. So just kind of, you want to think about that scale as you're working through these. So then the range is going to be -2 to 2, though. That's nothing crazy. Just what we've been seeing. All right, let's look at one more here, and then you can finish these up. So this is the only other case that we haven't talked about yet, is notice my equation here has a pi here and here. So this time there's something in front of that x value inside of the parentheses. Look down below here. See how there's a 2 in front of that x in the parentheses? And then there's a pi inside of the parentheses. Since there's a 2 by the x in front or inside of the parentheses, unlike these other examples where the b value was out in front, out of the parentheses, what that means is before we can find the b value, we're going to have to factor out this number. So this number was already distributed since it's touching the x inside of the parentheses. So we want to factor this out. So our b value, the number in front of x, we have to factor out before we come up with that horizontal shift. So factor out b before shifting. So in this box here, what we're going to put is, well, what do we get when we factor out? So this equation here is going to turn into y equals 3 plus sine, factor out a pi. So we have x plus, this is just going to end up being a 1. Right? So if I were to distribute that pi, I would get exactly where I started. And in terms of graphing, let's go ahead and put that +3 at the end because that's where we normally see it. So we have sine pi of x plus 1 plus 3. So then from here, it's exactly the same thing that we've been doing. So I think from here, you'll be fine with finishing this one. But let's just talk about number 5. Let's talk about how you would rewrite it. So this is your new equation for number 4. So just go ahead and graph it using the same strategies. And then for number 5, you need to factor this b value out because again, it was already distributed. You need it to be out in front of the parentheses in order to have an accurate horizontal shifting or in order to be able to figure out the horizontal shift. So if I factor that out, so it's going to be y equals -1/2 cosine. We're going to take a 2 out. So for this, you're taking a 2 out of the pi. So it's basically you're just dividing the pi by 2. So it's going to be plus pi over 2 and then close your parenthesis plus 1. Again, check distributing. If I distribute, I get 2x plus pi. We're good to go. It's the same. And you'll just go ahead and graph this just like all of the others. So I think from here you're in good shape. So go ahead, finish up these other problems. And then if you have any questions, just make sure you ask. And answer keys are posted as well. So if you need those, you have access to those.